So we've got a question here. We want to show cosine 3 theta divided by sine theta plus sine 3 theta over cosine theta equals 2 times cotangent 2 theta. So we need to manipulate this side to make it look like this side, or vice versa. Now, one mistake not to do is to see I've got 3 thetas here and 1 theta and just cancel out and put that as 2 theta. We can't do that. The input for the trig values have to stay as they are, and we have to manipulate them accordingly to the way we want to make them look in the end. So what we want to do here is use some trig identity to break down cosine 3 theta, because sine theta, cosine theta, that looks fine as it is at the moment. So what we want is for cosine and sine, if we have a look at the input, we've got 3 theta. Now we could write that as 2 theta plus theta, and that'd be fine to write that in the input. So therefore we can use the sum rule for cosine and sine. So the sum rule for cosine, what we could say is the cosine of a plus b. So in this case we'd maybe set a to 2 theta and b to theta. That equals cosine a cosine b minus sine a sine b. So that's the sum rule for the cosine. Now the sine rule looks similar but with a few subtle differences. So sine of a plus b, that's going to give me sine a cosine b. So this time we don't have the same ones in each side of the sine, this sine here, and now we have a plus sign instead of a minus, and this time we write cosine of a sine of b. So each one is flipped around on this side. That's how the sine sum rule works. So now what we could do is, if we set a equals 2 theta and b equals theta, we could use the sum rule for our numerators in these fractions. So let's go with that and see where that takes us, because it looks like if we've got a 2 theta, something good might happen here to end up with a 2 theta just like we've got on the right hand side. So that seems the way to go. Okay, so cosine 3 theta. Let's break that up with this in mind. So now we've got cosine of 2 theta times cosine of theta. So we're still on this one, and then we've got this one here minus sine of 2 theta sine of theta, and then that's all over sine theta. So that's what that one taken care of. Now let's do this sine theta. So sine 3 theta. So sine 3 theta, that will give us sine 2 theta cosine theta, and plus cosine 2 theta sine theta all over cosine theta. Okay, right, now that's a great start. Now we don't need to worry about this side for the moment. We're going to try and make this look like that. So what can I do now? Well, I could maybe divide by sine theta, but I'll be back to where I started. That'd be no good to me. So let's try and mix the fractions and get a common denominator, because then what will happen is this side I'm going to have to multiply by cosine theta, and as I've got the cosine theta here, I've got cosine squared theta, and if I do the same, I've got a sine theta here, I could end up with a sine squared theta. Now, when you get a cosine squared theta plus sine squared theta, if I just write this down, cosine squared theta plus sine squared theta, that comes down to 1, and then be good things to cancel out from there onwards. So let's do that. Let's get a common denominator. So now we've got sine theta cosine theta. Right, let's see where this takes us. So now I need to multiply this side by cosine theta. So let's do both of these terms here. So if I do this one, I'll have cosine 2 theta and cosine squared theta. So that's good. And then I've got to subtract this one and multiply all of this by cosine theta. So now I've got minus sine 2 theta, cosine theta, sine theta. Okay, right, well that's looking good. And I've got cosine theta, sine theta, just like my denominator. So good things might happen here in a moment. Let's see what happens. And then this side, multiply all of this by sine theta. So now I'm going to add sine 2 theta, cosine theta, sine theta. Cosine theta, sine theta. And here, cosine 2 theta, sine theta, sine theta. So that's sine squared theta. So plus cosine 2 theta, times sine squared theta. Okay, right. Now I've got a cosine 2 theta, cosine squared theta, cosine 2 theta, sine squared theta. So let's combine those two together. So now I've got cosine 2 theta with cosine squared theta plus sine squared theta. Now we know what that is. I've just written it on the side so as we can see how we're going to break these down. So that's that part and that part. Now what we've got inside here. Now here I've got cosine theta, sine theta with sine theta minus sine 2 theta. So let's factor out cosine theta, sine theta. So we'll worry about the sine for that in a moment. And then what goes with that is sine 2 theta minus sine 2 theta. So that's all of that. Now, whatever happens here, I'm going to end up with 0. So this is going to be 0. So whether I add or subtract a 0, this whole thing would just disappear. So if I look carefully here, I've got a minus sine 2 theta on this side. So if I put a minus 1 here, it doesn't matter which way it goes, because I'll have minus this one, which is that one, and then that minus becomes a plus for that one. Or if I put a plus, I'd have a plus for that one, and then a minus for that one. So it doesn't matter what side I put, they're all going to cancel out, and all of this will disappear and become 0. And now I need to just divide this by sine theta, cosine theta, and that's all I've got left. Okay, right, well this just becomes 1. So it doesn't cancel out, it just becomes 1. So now I'm just left with cosine 2 theta over sine theta, cosine theta. Okay, well, cotangent 2 theta, let's just write what that is. So cotangent of 2 theta, that's cosine 2 theta divided by sine 2 theta. Now I've got cosine 2 theta here. Does this thing here become sine 2 theta? Well, let's have a look at our sum rule here, because that looks like part of it. So sine and cosine I've got in here. Both of those have got sine and cosine compared. So I've got theta and theta. Now let's imagine I've got sine of theta, cosine of theta. That's half of that. Well, that would mean my input would be sine of 2 theta. So if I just write this as here, sine of 2 theta, that equals sine theta cosine theta plus cosine theta sine theta. Well, as these are both equivalent on this side, oh, don't want the bracket there, do I? I want the bracket there. As this, any one of these here is equivalent to this, I've basically got a half of this. So this then here just becomes a half of sine 2 theta. So now I've got cosine 2 theta divided by 1/2 of sine 2 theta. And now I've got the sine 2 theta that I want, and with a half. So now that is going to give me 2 times cosine 2 theta over sine 2 theta, which then gives me 2 cotangent 2 theta. And that's exactly what I wanted. So using the sum rule and a couple of trig identities here, everything's perfect, and we've got 2 times cotangent 2 theta, which is just what we wanted. So that's the first part of this question. Now I'm going to use this again now to try and find some values for theta. Okay, so now I've shown that this is equivalent to this, 2 cotangent 2 theta, but now I've set it to equal to 4, and I want to solve for theta, which is between 90 and 180 degrees. So let's see if we can solve that. So 2 cotangent 2 theta equals 4. So that's all good, but nothing I can do there. Now I know that cotangent of any angle, in this case it's 2 theta, is just a reciprocal of the tangent function. So that's what we got there. So let's substitute that into this. Well, if I multiply that by 2, I'll just have 2 over tangent 2 theta. So 2 over tangent 2 theta equals 4. Okay, right, let's bring this over to the other side. So 2 equals 4 tan 2 theta. Okay, well, I can divide everything by 2. That'd be a good start. So now I've got 1 equals 2 tangent 2 theta. Okay, now tangent 2 theta. Now I've got a trig identity I can use for that. So tangent of 2 theta, that just becomes 2 tangent theta over 1 minus tan squared theta. So I can substitute that for that. So let's just do that. So now 1 equals 2 times 2 tan theta over 1 minus tan squared theta. Okay, now that's going to be good. I can bring 1 minus tan squared theta onto this side if I multiply both sides by this. So now I'll have 1 minus tan squared theta equals 2 2's are 4, 4 tan theta. Okay, well, I've got tan squared, I've got tan, and I've got a 1. So why don't I bring everything onto this side, set it to 0, and I've got something that looks a little bit like a quadratic. So if I bring this all over here, I would have tan squared theta, I'd have plus 4 tan theta, and bringing this over to this side, I'll have minus 1. And then set all that to be 0. And yeah, that looks like a quadratic. So quadratic formula, let's write that up, stick it in a box. So I've got, in this case, we're solving for tangent theta. So now we've got minus b plus or minus the square root b squared minus 4ac all over 2a. So in this case, a is 1, b is 4, c is minus 1. Okay, right, let's go down here and let's work this out. So tangent theta, that equals minus b, so that's minus 4, plus or minus square root. B squared is, 4 squared is 16, minus 4 times a times c. 4 times a times c, that's going to give me minus 4. So put minus 4 in there. So minus minus 4. And that's all over 2 times a, which is 2. Okay, right. So now we've got minus 4 plus or minus square root of 20 over 2. Now, square root of 20, can we break that apart? Well, square root of 4 goes into that. So square root of 4 times square root of 5. So if I just write up here, root 20 equals root 4 root 5, which then equals 2 root 5. So now I've got minus 2 plus or minus 2 root 5, so that's minus 4 over 2. So now cancel each of the 2's out. That cancels with that, and that becomes 2. So now I've got tangent theta equals minus 2 plus or minus square root of 5. Tan theta equals minus 2 plus root 5, or tan theta equals minus 2 minus root 5. Right, so we want values of theta between 90 and 180. This is the important bit for us. Now, in the unit diagram, tangent, remember we've got here A, S, T, C. Tangent is only positive here and here. So here it's negative. So this is the 90 to 180 bit that we're interested in. That's what we want. So we need a negative value. Well, square root of 5 is just above 2. It's about 2.2 something. So minus 2 plus that, that's going to yield a positive number. So that will either yield this value or this value in these 2 quadrants. So this one is not going to be valid. So we're going to have minus 2 minus root 5. So therefore, that's the one we want. Now what we want now is to solve for theta. So if I just put a line under this. So now theta equals the inverse tangent of minus 2 minus root 5. Now, if we put that into our calculator, theta is going to be approximately 103.28 blah 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 blah. So that's the value we want in this quadrant. So that is going to give us our answer for our theta. Okay.